Now it's your turn to determine if a graph represents a function and state the domain and range for that relation. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. To determine if each of these graphs represent a function, I'm going to use the vertical line test. And so I've grabbed a ruler, and what I'm going to do is to check if a vertical line passes through either of these graphs more than once. And so as I look at each of these vertical lines, I can see in this first graph that it only passes through at most once. I can see over to the left here it doesn't pass through at all. That just means that this is a function, but it has a limited domain that does not include all real numbers. So this first graph does represent a function, so let's write that down. So is this a function? Yes, this is a function. And now let's check off the second one. So we can see that the second line, it goes from this point 1, 7, it comes down, goes back up. As it moves right, it comes down, it goes back up, and then it ends over here at 6, -7 with an open circle, and we'll talk about what that means momentarily. First, let's check if this is a function though. So grabbing a ruler, I can follow along here to check if there's a vertical line that passes through this graph more than once. And I can see that as I move left to right, every vertical line is going to pass through exactly once where this function is defined. So this is indeed a function, and I'll write that down. So is this a function? Yes, the second graph is a function. Now let's move on to the domain and range of each of these. So when we look at the domain, we're determining all possible inputs, and when we look at the range, we're stating all possible outputs. So if we come over to this first graph, I can see this point -2, 3, and then it arcs downward. It crosses that x-axis and continues arcing downward. I also see an arrow on the end showing that it continues indefinitely. When I determine all possible x values here, I'm going to highlight along the x-axis where this function is defined. And so I'm starting at -2, and I can highlight and I can see that it's going to continue on indefinitely. If I come down below this, I can see that -2, at that point -2, 3, the circle is filled in, which means that the function does exist at that point. So -2 will be included in the domain, and I'll go from -2 and have all numbers so I'll go have -2 and all numbers larger than -2. When I write that in interval notation, I'm going to use a square bracket on the left. I'll write a -2, and then to show that it continues on indefinitely for all numbers larger than that, I'll write infinity on the right and use an open bracket. Again, I use an open bracket on infinity because infinity is not technically a number, so I'm not going to include that. But -2, I do want to include that number, and so I use a square bracket on that left side. We'll do something similar for the range. Looking at all of the y values for which this function is defined, I can see that at this point -2, 3, and then down from there, this function is defined. So I'm going to highlight along this y-axis where this function is defined, and I go from +3 downward. And off to the side here, I'll sketch that I go from +3 and include +3, and then all numbers smaller than +3. So the range includes all numbers 3 and smaller. When I write that using an interval, I need to note that 3 is the largest. So 3 is going to go on the right side of my interval, and because I am including the number 3, I'm going to put a square bracket there. To note that I also want all numbers smaller than that, I'm going to put -infinity on the left of this interval. And again, those are separated with a comma, and -infinity gets an open bracket. So the range reads that round parentheses bracket, -infinity, 3, and then a square bracket. So let's go to our second function and do the same thing to determine the domain and range. Looking at the second function, I can see that at the point 1, 7, there's a filled-in circle, and then the line kind of squiggles and goes down to 6, -7. But at 6, -7, there's an open circle, and that open circle means that the function is not defined at 6, -7, but it's defined everywhere right up to that point. So that open circle means it's not defined there. And I'm going to move this ruler out of the way so that I can continue marking off below this axis. Okay, so let's highlight along this axis where the x values for which this function is defined. So if we go from 1 and then over to 6, it's going to be those values, but it's going to include 1. So I'm going to come down below this axis and put a square bracket where 1 is. It's going to include 1, and then it's going to go up to 6, but not include 6. So when I write that domain, I'm going to write 1, comma 6. And on the left, I'm going to put a square bracket, and on the right, I'll put a rounded bracket, and that shows that the number 1 is included, but the number 6 is not included. I simply go up to 6 as close as I possibly can without including 6. Let's do the range now, and I'll similarly highlight along this y-axis, so I can see that from -7, but not quite including -7 because of that open circle, and then I'll come up, and I'll go all the way up to +7, and I will include +7. So I'll mark off off to the side here, open bracket at -7, all of those values, and then stop at +7. So when I write this interval, it's going to have -7, comma 7, and on -7 I'm going to put a rounded bracket because I don't want to include -7, I just want to go up to it. And then on 7 I'll put a square bracket because 7 does need to be included.